control systems with embedded implementation. The coursework we're going to be doing today is the design of the control system for heating chamber. It's a good coursework, so the people involved are Benjamin Asbu, Moses Ipadiola, and Moshid Adiaga. So for this assignment, we're going to be using the following tools: LabVIEW. This is going to be the software to program the devices we're going to be using. And here is the power supply. Here is the compact wheel. And the following one is the heating chamber, which consists of a lamp, which is going to be used to heat the system, a thermocouple. This is going to be used to act as a temperature sensor, and a fan in the background for cooling the system. And also, we have 4 LEDs in the front and 3 switches. Okay, so here's the LabVIEW project. The LabVIEW project consists of some main parts. One of the main parts is the safety trigger switch. This is the section. This acts as a master override switch for the entire program. So when this is clicked on the front panel, we expect it to disable every system. To disable the system, and every operation is gonna halt. Here's the PID controller. This consists of the main part, the input. This is used to set the target temperature for the system. This is the thermocoupler. This is coming from the compact wheel, and it acts as the thermocouple. This is used to state the temperature, and the KP, the KI, and the KD inputs of the PID controller. And here we have where the fan and the lamp are adjusted, controlled using the output from the PID to control both the lamp and the fan. And in this section over here, we have this section is mainly used to control the temperature so that it doesn't exceed 55 degrees. So when the temperature does exceed 55 degrees, as the temperature is coming from the thermocoupler, it will perform these actions such as switching off the lamp, the fan, and LED, and it will turn on an LED to indicate this. And here's the front panel. It consists of 2 graphs. One graph, this shows the temperature of the system, and this shows the output from the PID, the pulse width modulation. And here we have inputs. These inputs are the inputs that we input into our PID controller, the KP, the KI, and the KD. And the input right there, this is to set the target temperature of the system. And here we have the output, the temperature of the system, the PID output, the pulse width modulation, and our error. And here in this corner, we have the safety trigger. This is the master override that was shown earlier on, and it will be used to disable the system and halt all operation while the system is running. So we're going to be demonstrating the working system. So at first, the purpose of the system is to keep the temperature at the certain target temperature, which we're going to set. Let's do this. So first, we're going to show our desired temperature at the moment. So let's say 35, and then we're expecting the lamp to go on. The lamp will be adjusted as the temperature increases and gets closer to the target temperature, as you can see. And also, if you pay attention, the LED 2 will be also on. This is to indicate that the lamp is on. Another thing you can pay attention to is the graph. You can see how it's showing that our temperature is now steady at 35 degrees, and you can see that we haven't got any overshoot or undershooting point. Another thing you can pay attention to is the PID. This is the output coming from our PID controller from here. Now that we show that our temperature maintains its target temperature, now we're going to try and drop the temperature and see if it actually drops. What we're expecting is the system will cool down using the fan, and it will drop up to 30. So let's say drop our temperature by 5 degrees back to 30, and the fan comes on, and LED 2 also comes on. Now the LED it just, as you can see, our temperature just back to 30, and it tries to maintain it using both the fan in conjunction with the lamp to maintain this target temperature. Now, another thing that's been mentioned in the coursework specification is to make sure we have a safety trigger. The purpose of the safety trigger is to make sure, like, if anything was to happen, we'll be able to halt all operation from that system. So our troubleshoot is located right in this corner, and while the safety trigger is pressed, all operation is going to be come to halt from the system. And so let's go ahead. As you can see, the minute I press the safety trigger, everything is stopped, and LED2 is on from the heating chamber construct to indicate this. LED1 to indicate that the safety trigger has been triggered. Now, if we go back to the program, we can see that turning on switching back to toggle switch to its default position will start the system again, and the system operation will resume. And finally, our system, in the specification of the coursework, our system has been specified not to ever exceed 155 degrees Celsius. So what we're going to do is, like, to show that the system would not exceed 55 degrees, let's set the system to about 60. Setting this will be expecting that the temperature will never reach that 60, because as soon as it gets to 55, the lamp from the system will switch off. A warning message will be displayed in this section, and also an LED will be on to identify, to show us that the system has reached this certain 55 degree.
Which LED is going to show?
LED 1 is gonna go on to show us this.
LED 4.
LED 4 will show us this. So I'm gonna go ahead and just click this to set 60. As you can now see, our temperature, after waiting for a while, our temperature has now reached 54 degrees, and what we'll be expecting is that when it eventually reaches 55 degrees, we're going to be expecting a warning message to pop up there briefly. Also, the lamp will go off, and
LED 4
will go on. So as you can see,
just a few seconds to indicate that the temperature is above 55 degrees.
Also, one thing you must notice is that because our temperature is been rounded off, so 55, the error rate is 55, so we would be expecting, before the error message pops up, the temperature will have to be at a value of about 55.5. so that will be, we'll see that very shortly.
There.
As you can see, that happened briefly and quite fast. But if you pay attention to the morning, now that the temperature is closer to 55, and just notice, as you can notice, that the message is popping up, and our lamp goes off, and also
the fourth LED
will come on. The reason why the temperature doesn't, the message doesn't stay is because due to the fact that the lamp turns off, this drops the temperature, so the temperature goes below 55, so the morning message is already shown briefly, and the lamp and LED turn on and turn off respectively, just briefly. So this concludes our demonstration of the system. This concludes our demonstration of the system. Thank you for watching.